So we are going to discuss about process scheduling. So in this process scheduling, first we are going to discuss about the types of queue. So job queue, ready queue and device queue. So job queue is used when the process wants to move from the new state. So from the new state, I want to move to the ready state, means I will be using the job queue, and then the ready queue is used to move the content from, or it is used to maintain the process which are ready for execution. So that will be loaded in the ready queue, and then the device queue, whichever whenever I need any IO devices, means so that requests will be that device executions will be put it in the device queue. And this diagram represents, so what are the reasons the process comes out, and it will be placed in which queue. Okay, so if the process wants to do any IO operation, then the process will comes out to the CPU and it will be loaded in the IO queue. Okay, so in other cases, if the process time slice happen, means what happened, directly it will go to the ready queue instead of placing in any queue. Okay, and in the if the process wants to execute any child process, means so what will happen, it will first come for the child process. So it will go to the waiting state, it will go for the, it will do the child process execution, and again it will go back to the ready queue. Again the CPU, if any high priority job is received, the CPU will move the current execution process directly to the ready queue, and then it will go and will do the high priority process job. Okay, so these are the reasons, and the how the at what reasons a process comes out of the processor and it get into the ready queue for doing its execution. The next one is schedulers. We have three types of schedulers. One is short-term scheduler, long-term scheduler, and medium-term scheduler. So the short-term scheduler, which is used to execute the next instruction, which is ready for or which is waiting for the CPU time. Okay, so basically the short-term scheduler will be used between the schedule the task between the ready to the running state. Okay, in the long-term scheduler, if I want, if a new process reached in the new state, means so this long term scheduler is used to travel or used to transfer the job from ready to the running state. Okay, so in this case the process identified by two things: IO bounded process and CPU bounded process. So IO bounded means if the process wants to perform any IO computations, means so then it will be having a less time period. So some process purely depend on the CPU, so that time the process CPU CPU utilization will be more, and the process needs more CPU time for completing the execution. The next one, in that case, we will be going for the medium term scheduler. So if any interrupt or any IO process is coming, so what will happen? It needs to move the process to the suspended state, and then it will go for the, and it will time will be given for the new state. Okay, so when moving the process from main memory to the secondary memory, what will happen, we will be using the medium term scheduler. So these are the types of scheduler we are having. The next one is, what are the reasons for process creation? So these are the four main reasons for process creation. The first is the new job. Then when the user start into the system, so that is interactive login. Then created by OS. So OS itself creating some service to perform some applications or performing some tasks. OS itself creates some process to provide some services, and spawned by existing process. So like if parent process creating the child process for doing the parallel operation, so in that case the new process will be created. So this is a reason for four main reasons for process creation. Then there are many reasons for process termination. So one is a normal completion, if the time limit exceeds, or if the memory is unavailable, or if it's going beyond the privilege memory location, or if there is any arithmetic error, or if the time slice expired, or if any instructions are invalid. Okay, so these are if the parent process completed, or if the parent request for the child process completion. So these are the reasons for process termination. And reason for process suspension. So what are the reasons for process suspension is due to the swapping. When the process is waiting for a long period but any process wants to execute means, so that time the process which is currently executing but it's waiting, it's entered into the waiting state, means in that case process swapping will happen. Or due to other reasons, for any to perform any background things, background operations, so OAS will suspend the current process. And interactive user request, based on the user request, the process will get suspended. For example, if you're running a process based, if it's taking more time and you want to perform some other task, means as a user we can go to the end task, and then we can stop the operation, right? So that is the case of interactive user request. And timing, parent process request again. So these are the reasons for process suspensions. So up to this we discussed about process scheduling, so types of schedulers, then what are the reasons for process comes out of the processor, and what are the reasons for process creation, termination and suspensions. Okay, thank you.